Hi, this is the second lecture for chapter one for software engineering T200. We will look into quality attributes today. So, what are quality attributes? Quality attributes are our compass for choosing the right architecture style. They guide us to satisfy the requirements perfectly. We identify these attributes during the requirement analysis phase. That is the first phase when we talk with client and we gather the requirements, setting the stage for what's important in our design. They fall into three main categories. These are um, implementation attributes, runtime attributes, and business attributes. So first, implementation attributes. These are behind the scene heroes, not visible at runtime, but crucial for development, like modifiability and maintainability. So basically, if you have a piece of code or a software, how do you maintain that? So these kind of which attributes are important for those implementation. These are implementation attributes. Then we have runtime attributes, the ones that shine when the system is running, like the performance, security, and usability. These are what users experienced firsthand. And finally, there are business attributes. These relate to the big picture um, goals of the organization, like cost, time to market, and longevity. By understanding these attributes, we can tailor our architecture to meet both technical and business needs, ensuring well-rounded, effective system. Let's zoom in implementation attributes. There are These are the secret ingredients that make sure our software can be developed, maintained, and evolved smoothly over time. Attributes like reusability, extensibility, and maintainability ensures our system can adapt to future changes, remain cost effective and reliable, no matter what comes its way. Take interoperability. For example, it's all about making sure our system can talk to different parts of the outside world, easily exchange data. It's like having a universal translator. This requires loose dependency on infrastructure, making connections seamless. Then we have maintainability and extensibility. The ease with which we can tweak, update, and expand our system, keeping it fresh and relevant. And don't forget testability, the ease of setting up test cases to ensure everything works as it should. This usually needs comprehensive documentation paired with a well thought out design and implementation. These attributes are like the backbone in a strong and flexible software system, ready to handle whatever the future throws at it. Let's explore three more crucial attributes that help shape resilient software systems: portability, scalability, and flexibility. First up is portability. This is all about how well our software can move across different platforms. Think of it as a world traveler. Systems built with high level programming languages like Java usually score high here. You write the code once and it can run anywhere, making portability a big win. Next is scalability, the system's ability to handle more and more user requests without breaking a sweat. It's like adding more lanes to a highway to prevent traffic jams. Good scalability means avoiding bottlenecks in the system, ensuring smooth operations as demand grows. Lastly, there's flexibility, how easily your system can adapt to new challenges and or environments it wasn't originally designed for. Systems built with component based or service oriented architecture typically excel in this area. Flexibility means you can tweak and expand your system as needed, keeping it relevant and efficient. Together, these attributes make sure our software can grow, adapt, and thrive in different environments, standing in the test of time. Let's talk about runtime attributes. These are the game changers that directly influence user experience and system maintenance. Think of them as the heartbeat of your software, keeping everything running smoothly under various conditions. First, there's availability. This is all about making sure the system is up and running when users need it. It's like the light always being on in a store. Achieve high availability might involve replication or robust design strategies to handle hardware, software, and network failures. Then we have security. The systems shield against attacks, whether from outside or inside. Imagine a fortress protecting your data. Boosting security involves tools like firewalls, setting up solid authentication and authorization processes, and using encryption to keep data safe. And finally, there's performance, how efficiently the system operates in terms of response time, throughput, and resource use. It's like having a high speed sports car that's also fuel efficient. But remember, these attributes often play tug of war with each other, so finding the right balance is the key. Together, these runtime attributes ensure that the system not only works but works well, providing a reliable and secure experience for users. There are more runtime attributes. For example, usability. It's all about how satisfying and intuitive the system is for users. It covers everything from having a friendly user interface to providing complete documentation and solid technical support. It's about making users say, wow, the system is easy and enjoyable to use. Next, there's reliability. The rock solid foundation of your software, it measured by how often the system fails, how accurate its outputs are, and how well it can bounce back from failures. Metrics like mean time to failure or MTTF help gauge this. The reliable system makes users feel they can count on it, rain or shine. Finally, we have maintainability, adding new features or adapting to new environments. It includes aspects like extensibility, adaptability, testability, and configurability. A maintainable system is like a flexible toolkit, ready to evolve as needs change. Together, these attributes ensure that the software not only meets today's needs, but is also ready for whatever tomorrow brings. Let's focus on the big picture now, business attributes. These are the characteristics that align our software system with the overall business goal, making sure the software isn't just technically sound, but also makes good business sense. Time to market is a crucial factor. It's all about how quickly we can go from the initial requirements analysis to launching the product. The faster we can do this, the better we can capitalize on market opportunities. Then there's cost, total expense of building, maintaining, and running the system. It's important to keep costs in check to ensure the project stays profitable and sustainable. Lastly, we have lifetime, how long the product remains useful and operational before it's time to retire it. A longer lifetime can mean better return on investment, but it also requires good planning for future updates and maintenance. By focusing on these business attributes, we ensure that the software not only meets technical requirements, but also supports the financial and strategic goals of the business, setting the stage for a long term success. Balancing software design is often like walking a tightrope. There are trade offs to consider, and it's up to software architects to find the right balance among different attributes. Here are some classic trade off pairs. First, we have the trade off between space and time. Um, Imagine a hash table. If we want to make it super fast, it might take up more memory space. So improving time efficiency can lead to decrease in space efficiency. Next is the trade-off between reliability and performance. Take Java, for example. It's designed with security features like boundary checks on arrays to prevent buffer overflow, making it more reliable. However, these checks slow things down compared to C, which is faster but less secure due to its use of pointers. Finally, there's the trade-off between scalability and performance. To make a service more scalable, we might replicate servers. However, ensuring that all of these servers stay consistent can slow down overall performance, like trying to keep everyone on the same page in a big meeting. Navigating these trade offs is a key part of the architect's job, ensuring the software meets both technical and business goals effectively. Now, let's look at software architect design guidelines. Design abstracts. Let's talk about the power of the abstraction in software design. Starting with an abstract design means specifying interfaces and abstract data types right from the get go. This sets a solid foundation, like sketching out a building's blueprint before diving into the details. Abstract interfaces are defined early in the development cycle. They act as the contracts between service providers and requesters, making them more stable than concrete implementations. By focusing on these abstract interfaces, you can make decisions that are flexible and adaptable, setting the stage for a design that can evolve over time. Remember, it's about what to do before getting caught up in how to do it. By keeping things abstract initially, you keep your options open, allowing for more innovative and efficient solutions as the project progresses. Non-functional requirements might not grab headlines, but they're just as crucial as functional ones. It's important to consider them early on the analysis phase. By doing so, we ensure our design meets all needs, not just the ones that are visible on the surface. As you map functional requirements to the architecture design, keep non-functional requirements in mind. These includes things like performance, security, and usability. They shape how the system perform under the hood. Don't forget to communicate with stakeholders. Their input on quality attributes is key. They will help you understand what's important from a user and business perspective. Documenting their preferences ensures that everyone is on the same page. Finding the right balance among these requirements might mean using heterogeneous architecture styles. If not all quality attributes can mate with a single style, mix it up. Use different styles in different parts of the system to achieve the best overall outcome. It's all about crafting a well rounded, effective solution that ticks all the boxes. Always keep an eye on the future. When designing software, planning for future additions is key. One of the best ways to do this is by making your software components reusable. Reusing existing components not only saves time and money, but also boosts reliability since you are using proven solutions. Think of it like building with Lego bricks. Each piece can be used in countless different ways, making it easier to expand and improve over time. By striving to design software that is extensible, you create a flexible foundation ready to adapt to new requirements and developments. Extensibility means your software can grow and evolve without needing a complete overhaul. It's like planting seeds today that can blossom into new features tomorrow. This approach ensures that your system can keep pace with changing needs and stay relevant in the long run. In software design, two guiding principles can lead us to greatness: high cohesion and low coupling. These are like the secret ingredients for creating robust and flexible systems. High cohesion means that each element, whether it's a subsystem, component, or module, is focused and has a single well-defined responsibility. In object-oriented design, this might mean ensuring that each class does just one thing. Think of it as a master of one trade rather than a jack of all trades. On the flip side, low coupling is about reducing interdependencies between these elements. This is like having neighbors who are friendly but not in each other's business. Techniques like message passing, and asynchronous communication promote loose coupling by allowing components to interact without being tightly bound. You can even measure coupling using interface signature counts. Fewer interactions mean looser coupling. This approach makes sure that the changes in one component have minimal impact on others, keeping the system adaptable and easier to maintain. By aiming for high cohesion and low coupling, you create a system that's both strong and flexible, ready to handle change in any way. Design ambiguity and detailing. Remember, designing software isn't about getting it perfect in one go. Think of it more like a sculpturing a masterpiece over time. Don't expect a perfect design in one step. Instead, use prototype and iteration to refine and improve the design gradually. So use prototype and iteration to refine and improve design gradually. Each version you will get you closer to your ideal solution. An ambiguous design can lead to confusion because it lacks the necessary constraints to guide developers, leaving too much open to interpretation. On the other hand, an over detailed design can restrict the implementation, shifting creativity and reducing flexibility. It's like giving an artist a coloring book instead of a blank canvas. The goal is to find the sweet spot between providing enough detail to guide development and leaving enough room for flexibility and innovation. By refining through prototyping and iteration, you will develop a design that's both clear and adaptable, ready to evolve with the project. Let's talk about UML diagrams and the visual superheroes of software design. They provide graphic notations that help us see and understand different stages of the software development lifecycle. Here are some key types of diagram. Use case diagram. These are like the wish list of the system. They document what users need and how the system should behave to meet those needs. Class diagrams. Think of these as the blueprints of the system's structure. They lay out the logical relationships and structures between different elements. State machine and interaction diagrams. This captures the action. They specify the dynamic behaviors of the system, how it responds to events and interacts over time. And there's a 4+1 view model. It's like having a multi-angle camera for your project, analyzing different views on both functional and non-functional requirements. This helps us to see the system from various stakeholders' perspective, ensuring that everyone's needs are met. Finally, we have architecture description language or ADL. This prevents different views of a software system from various stakeholder perspective, giving us a comprehensive picture of how everything fits together. Using these tools, we can create clear, detailed, and flexible design guide that development processes effectively. Creating a successful architecture design is like building a bridge that connects all the needs and concerns of different stakeholders. It's not a one time effort, but an iterative requirement analysis that adapts and evolves over time. Each stakeholder brings their own priorities to the table. Investors care about the bottom line, things like the release date, budget, and usability. They want to see a return on investment and a product that appeals to the users. End users are all about experience. They are focused on performance, reliability, and how well the system fits their usage scenarios. Software architects are the planners, balancing what's needed with what can be traded off. They perform trade-off analysis of quality attributes to craft a balanced and effective architecture. Software developers are in the trenches, focusing on implementation. They need to know what the software design is detailed enough for them to code effectively. Software project managers look at the big picture. They are concerned with the evolution of software architecture and its future maintenance, ensuring the system can grow and adapt over time. By understanding and addressing these the diverse concerns, we can design a software architecture that not only meets the technical requirements but also aligns with the business goals and user needs. It's all about finding the sweet spot where everyone's happy. So this is the end of chapter 1. From next class, we will start studying from chapter 2, the software design and architecture.